This PowerPoint is going to be talking about how the stuff that makes up how we classify matter. Okay, how we classify, how we categorize it. All right, matter is just the stuff that makes up all things. Okay, the atoms, molecules, etc. All right, and there's really two broad categories. This is a good one. There's a pure substance. All right, and then there's mixtures. Okay, and really all matter can fall into these two broad categories. Right, so these are the two broad categories, substance and mixture. Now, a substance, a pure substance, a lot of times that's how I'm going to refer to it as pure. I might as well spell it. A pure substance can be broken down into an element, which is the most basic. That is the most basic type of matter. All right, and then there are compounds. So there's elements, and then there's compounds. All right, mixtures can either be homogeneous or homogeneous, and heterogeneous. That's spelled wrong. All right, so we're going to break that down into what exactly those mean. Okay, so a pure substance, just to give you some properties that you're going to want to write in your notes, has exactly the same composition throughout. All right, meaning every atom or every molecule, everything that makes that up is the exact same. Okay, every sample of a substance has the same properties. It is fixed, uniform composition. So like an example of that would be like water. You turn on, if you have water. We're not going to use tap water. We'll just say water, H2O. Every single part in that water has two hydrogen atoms bonding with one oxygen atom. Okay, there's nothing else added to it. Now, tap water technically is a mixture because it has other things mixed in. It has like chlorine and other things that are mixed in. But pure water, just H2O, is a pure substance. It has the exact same composition. Everything in it is the exact same. All right, and so elements, to simplify this, elements are substances that cannot be broken down smaller. They're already at their most fundamental level. All right, so hydrogen, like these are examples of elements: copper, gold, hydrogen. And what I put in parentheses here, these are the chemical symbols. They're chemical shorthand for the elements. All right, we're going to talk about this a little bit later. But an atom is the smallest particle of an element in matter. All right, you can't break an atom down smaller into like protons, neutrons, electrons, which we will do later, but not while retaining the properties of the matter itself. Okay, and so an element, and when all the atoms are the same, that's an element. All right, and once you start breaking down the atom even further, then it doesn't retain the properties of that matter. Okay, so like hydrogen gas, you cannot break that down any simpler while maintaining the properties of hydrogen gas. Oxygen gas, gold, a gold bar, a solid gold bar, can't break it down further. Whereas a compound is a substance that is made up of two or more simpler elements, or two or more simpler substances, an element or compound. So like water. See, water, here's the formula for water, H2O. All right, H2O is there's two hydrogen atoms bonding with one oxygen. All right, so it's a combination of elements. Okay, so compounds are slightly more complicated. It's a combination of elements. Carbon dioxide, CO2. It's one carbon bonding with two oxygen. Okay, it's a combination of elements. Table salt, NaCl. Combination of elements. Okay, so elements are the most basic parts of matter. Compounds are when elements combine. All right, and the reason why these are different from a mixture, and this is going to be important, the reason why this is going to be different from a mixture is that they are chemically bonded together. All right, and it doesn't say that here, but a compound, it's a chemical bond that creates them. And I'll explain what that means in a little bit later down the road. All right, and here are just the first 25 elements in their shorthand, the chemical shorthand they have. We're going to usually focus on the first 20. Most of them make sense, but you'll look like some of them, you're like sodium, Na. That's weird. The reason why some of them, potassium, Ka, why is that? Some of them use the Latin prefix. All right, once again, we'll get into that more later. All right, well, our mixtures, okay, mixtures are physically mixed together. The properties are less constant than the properties of a substance. Okay, so there's two types of mixtures that we talked about. There's heterogeneous, All right, heterogeneous. The best way I say this is it's weird, but the best way I kind of can equate this is the same way when people talk about like sexuality. If you're a heterosexual, you like somebody that looks different from you, right? Like you like the opposite sex. So if you're a heterogeneous mixture, that means it looks different. You can see the parts are noticeably different. Okay, so a heterogeneous mixture, it looks different. If you think of like a salad. Get some onions, get some tomato, get a little salad dressing in that bad boy, get some, maybe throw egg in there, whatever, I don't know. That is, you can noticeably see the different parts that make that salad up. That would be an example of a heterogeneous mixture. Think of mixed nuts. That's obviously, you can see there's cashews, there's almonds, there's whatever. There's obviously different parts that make that up. They don't all look the same. And so heterogeneous means it looks different. You can see the difference, and I think you probably know where I'm going when I say homogeneous or homogeneous. The substances are evenly distributed, so it's still a mixture, but it all looks like it's the same substance. An example would be like if you really thoroughly mix Kool-Aid together, like that all looks like it's the same substance, like it's all just like one red liquid. But it's not. It's a mixture. Two things are physically mixed together to make it look like it's one thing, but it's really not. Okay. So heterogeneous parts you can tell are noticeably different. Homogeneous, they look the same, but the reason why this is different from a compound is because it is physically mixed together, whereas a compound there's a chemical reaction that occurs to bond those together. All right, so these can be separated physically. Now, we'll go into that more later. We'll talk about suspensions in a minute. Physical properties. Here are some examples of physical properties. Viscosity, how thick a liquid is, conductivity, hardness. I'm not going to get into this a ton, but we talked about like a conductor allows for heat to flow, allows for electricity to flow through it, etc. Malleability, how easily something can be hammered. Like gold is very malleable. That's why it's so precious, because it can be hammered into a very, very thin, a little tiny ring or necklace without shattering. Right? So it's very malleable. Hardness, diamonds are very hard. You can't scratch. I don't know if anything can scratch a diamond. Density, we've already talked about that, how compact the particles are. Melting points and boiling points, we've gone in and that process as well. All right, and physical properties are used to identify material, to choose a material for a specific purpose, or to separate substances. So there's different separation processes that we're going to go through. We're actually going to do this in class. We're going to have a couple separation. We're going to have several mixtures of things, and we're going to have to try to separate them. Once again, if it's physically separating things, then we know that it's a mixture, because mixtures are physically separated. All right, separating particles based on their size, that's called filtration. All right. If you think like tea or coffee, you put the coffee grounds into a filter, and then water pours over top of them, and then the water passes through, but it takes in some of that coffee flavor, but it keeps those separated. It doesn't mix them all together. Distillation is based on different boiling points. When two substances have different boiling points, even if it's two liquids, you could boil away the two liquids and be left, and that would separate them, because if they have two different boiling points, that would be one way. Like here it says water and vinegar. All right, so that's how you separate. Those are examples of separating a mixture through physical separation. All right, so a physical change, the properties are changed, but the substance remains the same. All right, so physical. When we talk about physical changes and physical, the substance is going to be the same, but the properties might change. Like melting, freezing, evaporating. So you can change what it looks like, but the substance itself, saying that water in liquid form is the same as water in frozen form. All right. And so when we talk about physical changes, a big thing that we're going to talk about is that when a physical change occurs, it all is still the same substance. It just might look a little different. Cutting a piece of paper, still paper, didn't change anything. Whereas a chemical property is when something has changed, when the substance has changed. It's when a chemical reaction occurs and new substances are completely created. And this is probably one of the weirdest things to wrap your head around. But with chemical properties, when we talk about chemical changes and a new substance is being created, right, that is crucial in understanding. And completely new substance is created. It's like you take hydrogen, which is a flammable gas. You take oxygen, which is a flammable gas, and then you put them together, and it creates something that we can't live without, which is water. All right, it's weird how just two things that are very, very different from each other can create something. Like sodium chloride, that's table salt. Sodium is a metal that explodes on contact with water. Chlorine is a yellow-green poisonous gas, but when you mix them together, not mix them, that's the wrong word. When they react together, they create table salt. All right, so the substance is completely different once it undergoes that chemical change. All right, and here are some examples of chemical properties. All right, so physical properties we've gone over. Chemical properties are like flammability, reactivity, toxicity, oxidation. You can kind of read through those and pause the video if you need to, because you're going to have to write down some properties that are chemical properties as well. All right. Reactivity is how well, once again, how readily something combines with one another. Let me go to, I don't want to do that one. This is what I wanted to go to. All right, and then evidence of a chemical reaction occurring, and this is going to be important as well. All right, evidence that a chemical change has occurred. Did it change color? Does it look like a new substance is there? Is gas present? All right, because when bubbles form, that's always a good indication. When bubbles form, that's a good indication that gas is being produced, like carbon dioxide, etc. All right, so those are ways to tell if a chemical reaction is occurring by identifying those changes. All right, so here are examples of chemical properties and chemical evidence of chemical reactions. All right.